In the last class, we learned till what average velocity was. Today we'll start with the distinction between speed and velocity. So for body with motion in a straight line, the magnitude of velocity is its speed. The speed is always positive . Why is speed always positive? Let's look at the definition for speed. So what speed is the rate of change of distance with time. So speed is distance traveled by time. Distance is always positive. Time is also always positive. Hence positive by positive always gives us a positive value. Therefore speed is always positive, whereas velocity depends upon the direction of motion. Like we discussed in the previous class, suppose if we take east as a positive direction and a body starts moving towards the west, then the body is said to be moving in the negative direction and its displacement will be negative. So once the displacement is negative, velocity is displacement by time, we get velocity also negative. So velocity can be positive or it can be negative. But velocity can be positive or negative depending upon its direction of motion. Second point of distinction, the average velocity of a body can be zero even if its average speed is not zero. One good example of this can be when you throw a ball in the upward direction. What happens is this goes up, reaches a maximum height and it starts coming down. Then slowly it will reach back to its own initial position. So first it went upwards, second it came downwards to its original position. So here the displacement is zero. So as the displacement is zero, therefore average velocity is displacement by total time taken. If the numerator is zero, the value is zero. Hence average velocity becomes zero. But here the average speed is not zero because the total distance traveled will have a certain positive value and also the time will have a certain positive value. So average speed over here is greater than 0. Another important topic we'll discuss as an example as well as the topic itself is uniform circular motion. Uniform circular motion. So what is uniform circular motion? When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Okay, let's take as this circle. So let this be the center and the radius be r. Suppose a body starting from a point A, moves in the anti-clockwise direction, completes one complete rotation and comes back again to A. And let's consider this body is also moving with a uniform speed. So in one rotation, distance traveled equals to 2 pi r, the circumference of the circle, average speed will become 2 pi r by t. But here displacement, as the initial position and the final position is the same, so displacement is the shortest distance between the initial and the final position, so that becomes 0. So over here displacement is 0. So average velocity also becomes 0. Okay. Also, when we look at this, what happens is at any instant, at any moment of time, what is happening is as this body is moving, it is moving with the uniform speed, means it is covering equal distances in equal interval of time. So the body is moving with uniform speed. It's given in the question itself, like if a body covers equal distance in the equal interval of time, the body is said to be moving with uniform speed. So by definition, it's written that when an object moves in a circular path with uniform speed, this means that it is covering equal distances in equal interval of time. So any moment we take in this whole circular motion, we see that the body is covering equal distance in equal interval of time. But at any instant, what is happening is its direction is changing. If we consider this instant, this is moving in this direction. If we consider this instant, it is moving in this direction. If we consider this point, so it is moving in this direction. In this point, this is moving in this direction. At every point of motion, it is changing its direction. Hence, the body is moving with uniform speed but non-uniform velocity. By definition of non-uniform velocity, we see if a body covers equal distances in equal interval of time with changing direction, it is said to be moving with non-uniform velocity. So uniform circular motion is a very good example of non-uniform velocity but uniform speed. Okay, since we were talking about speed at a particular instant or velocity at a particular instant, we'll also define instantaneous speed and instantaneous velocity. Instantaneous speed is the ratio of the distance traveled in a very short time to the time interval. And instantaneous velocity for a body moving with variable velocity the velocity of the body at any instant. Okay, with this we complete the topic speed and velocity. Up next we have acceleration. One observation that you must have made by now is that from the very beginning I have been mentioning scalar quantities on the left hand side and vector quantities on the right hand side. If you look at others also, distance was a scalar quantity, displacement was a vector quantity. For speed and velocity the same. On the left hand side we had speed, which was a scalar quantity, and velocity on the right hand side was a vector quantity. Now we are dealing with acceleration. Since acceleration is a vector quantity, this also I am mentioning on the right hand side. And since it is a vector quantity, we write an arrowhead at the top of A, its symbol. So acceleration is the rate of change of velocity with time. It is a vector quantity acceleration is given by delta V by t. Delta means change. So acceleration is change in velocity by time. So if we expand this, we get V minus U by t. A equals to V minus U by t. V denoting final velocity, U denoting initial velocity. V denotes final velocity and U denotes initial velocity. We'll just mention this as well, where V is the final velocity and U is the initial velocity of the body. Okay. SI unit of acceleration is velocity by time. Velocity is SI unit is meter per second. We are dividing again by time, so it becomes meter per second square. And CGS unit of acceleration is centimeter per second square. Okay. So we know A equals to V minus U by t now. So this implies AT equals to V minus U, which implies U plus AT equals to V. Minus U comes on the left hand side, becomes U plus AT equals to V, or we can write this as V equals to U plus AT. This is another important equations. So the formulas that you need to learn, I have put them in box. Please ensure you write all the formulas that are important in box, so that whenever you need to recall or revise the formulae, you can do them quickly. Acceleration V equals to U plus AT. Yeah. Note: Suppose while solving you get acceleration as -2 meter per second square. For example, then if you get the value of acceleration as negative, we call this as retardation, and the value of retardation will become 2 meter per second square. We do not take the negative sign for retardation. Retardation in itself means negative of acceleration. Therefore, negative acceleration, if you get the value of acceleration as negative, we call that as retardation, and we do not put the minus sign. So negative acceleration is called retardation. Okay. Again, we'll look at some definitions, some important definitions. Uniform acceleration. When a body has equal change in velocity in equal intervals of time, the body is said to be moving with uniform acceleration. Next definition, non-uniform acceleration, or let's say variable acceleration. When a body has unequal changes in velocity in equal intervals of time, the body is said to be moving with variable acceleration. Next topic, and the final topic, is acceleration due to gravity. Okay, so the earth pulls us with a certain force towards itself, and we experience certain acceleration due to that. That acceleration is called the acceleration due to gravity. So when a body falls freely under gravity, the acceleration produced in the body due to Earth's gravitational attraction is called acceleration due to gravity. As the term itself suggests, that acceleration due to gravity, when a body falls freely under gravity, the acceleration produced in the body due to the Earth's gravitational attraction is called acceleration due to gravity. Some notes relating to the same. Number 1. When a body falls down, its velocity increases with time. So, acceleration is taken as plus g. G denotes acceleration due to gravity. And when a body moves vertically upwards, its velocity decreases with time. So the acceleration is minus g. And the average value of g is 9.8 meter per second square. Why am I saying average value of g? Is because the value of g varies over places on Earth. We'll come to that point as well. The value of g, acceleration due to gravity, does not depend on mass. Okay, so if you drop a bottle filled with water down, or if you drop one whole almirah downwards, they will reach at the same point in the same time. But that is because their masses may be different, but the acceleration produced in both of them is same. You may argue in this case that a feather, when we drop a feather, the feather falls down very slowly as compared to the bottle falling down. This happens because the feather is aerodynamically shaped in such a way that it can fly swiftly in air. So it falls down very slowly because it gets pushed by the air upwards. But this does not happen in case of bottle. That is why the feather falls down slowly as compared to a bottle. But if you consider a bottle and an almirah, since air friction will not be that huge that it can change their speed to a very high extent, they will fall down almost at the same time at the bottom. Number third point. On the Earth's surface, G is maximum at the poles and minimum at the equator. The value of G decreases with altitude and also with depth from the Earth's surface. So suppose from Earth's surface you take a body to a certain height and you drop the body from there. So the value of g experienced at the top point at a certain height will be less as compared to the same g, the gravity acceleration due to gravity experienced by the body at the Earth's surface. At the Earth's surface it is the maximum. If you take it higher than the Earth's surface it will be less. If you dig deep and take it downwards, the acceleration due to gravity again will decrease. So at the Earth's surface it will be maximum. It will decrease with altitude and also it will decrease with depth from the Earth's surface. And on the Earth's surface, g is maximum at the poles and minimum at the equator. Okay. Now let us deal with some examples. Example 1. Express the speed 36 km per hour in meter per second. Solution. Okay. Why am I doing such a basic question is because these conversions are very important. If the question deals mostly in meter and second, then you need to have this converted in meter per second. And if the question deals mostly in kilometer and hour, so you need to have the unit in kilometer per hour. So say 36 kilometer per hour. So this is basically 36 kilometer per hour means by hour 1 kilometer is 1000 meters and 1 hour is 60 minutes and each minute 60 seconds. So 0 cancels off, 0 cancels off, 6 2 3s are 2 5s are. So we are basically multiplying 36 with 5 by 18 meter per second. So the value becomes 18 ones are 18 twos are 10 meter per second. So if you have to convert kilometer per hour to meter per second, you need to multiply with 5 by 18. And if you have to convert meter per second into kilometer per hour, you need to multiply with 18 by 5. It will just become the reciprocal. Take this down as a note. Second example. A train moving with uniform speed covers a distance of 120 meter in 2 seconds. Calculate part 1. The speed of the train. Number 2. The time it will take to cover 240 meters. Okay. For the first part of the question, we are given the distance and we are given the time. So to calculate speed is not a big deal. In the solution, first we'll write what is given to us. So S, the distance given to us is 120 meters. The time given to us is 2 seconds. Therefore, speed V will be equals to S by T, that equals 120 by 2. This is meter divided by second, so meter per second, which converts to 60 meter per second. For the second part, now we have the speed of the body. As the body was traveling with uniform speed, So the speed will remain same. So speed is 60 meter per second. The distance covered is 240 meters. We know speed v equals to distance by time. So this implies time. This is in division, comes over this side multiplication. Velocity will be in multiplication, comes this side division. So this becomes s by v, which will convert to 240 by 60. This is meter divided by meter per second. Meter and meter cancels off. Per second in the denominator goes to the numerator, becomes second. So this converts to 4 seconds. So we get time as 4 seconds for the second part. Third example. A train first travels for 30 minutes with a velocity of 30 km per hour and then for 40 minutes with a velocity of 40 meter per second in the same direction. Why is this in the same direction important over here is because the first part will calculate the distance or the displacement, and for the second part when we calculate the displacement we'll add both of them. If the direction was opposite, whatever displacement we got in the first part, we would have subtracted the second part from that, since they would have opposite direction. Now since they are moving in the same direction, we will add them up. Since they are traveling in the same direction, so displacement will add up to increase. Calculate. Number 1, the total distance traveled. And number 2, the average velocity of the train. Solution. Okay. So this one will divide into two parts. For the first one, the velocity is 30 km per hour. Time is 30 minutes. So 30 minutes converts to 30 by 60 hour, that is half hour. And V2 is given to us as 40 km per hour. I'm really sorry about this. This is not meter per second. This should be kilometer per hour. So V2 is 40 km per hour. T2 is 40 minutes. So 40 minutes when converting to hours, 40 by 60 hour, 0, 0 cancels off, 2 2s are, 2 3s are. So this is 2 by 3 hours. So S1 will become equal to V1 into T1. See, velocity is distance by time. So displacement will become velocity into time. So S1 is V1 into T1, that is equals to 30 into half kilometers, which is equals to 30 into half will become 50 kilometers. And S2 is V2 into T2. V2 we have as 40 km per hour and t2 is 2 by 3. So 40 into 2 by 3, which is equals to 80 by 3 kilometers, which is equals to 3 2 is 6. We have 20 in hand, 3 6 is 18. We have 2 in hand. 26 2 by 3 kilometers. So total displacement will become S equals to S1 plus S2, that is equals to 15 plus 26 2 by 3. So 15 plus 26 2 by 3 will turn to 20, 30, 40, 1, 2 by 3 kilometers. And for the second part, we need to find the average velocity. So average velocity will become S1 plus S2, the total displacement by the total time taken, T1 plus T2. So S1 plus S2 is 41 2 by 3, which converts to 3 ones are 3. 41 into 3 is 123. 123 plus 2 is 125. By T1 plus T2 will become 1 half plus 2 by 3. So half plus 2 by 3. S1 plus S2, let's write it directly only. This should be 125 by 3, not 125, 125 by 3, yeah. So this becomes 125 by 3 into this will become 3 plus 4 is 7 by 6. So 7 by 6. 3 ones are 3 twos are. This does not cancel off. So 125 into 2 is 250 by 7, that is 7 3s are 21, 40, 7 5s are 35, we have 5 in hand. So 35, 5 by 7 kilometer per hour. This is our average velocity. And the final question that I will discuss, that is a pebble thrown upwards with an initial velocity of 50 meter per second comes to a stop in 5 seconds. Find the retardation. Solution. So initial velocity u is given to us as 50 meter per second. The final velocity, it comes to a stop. So final velocity becomes 0. The time taken is 5. So acceleration is final velocity minus initial velocity by time. Final velocity is 0 minus initial velocity 50 by time taken is 5 seconds. So minus 50 by 5 is minus 10 meter per second square. So acceleration is negative. Negative acceleration is basically retardation. So retardation becomes 10 meter per second square. So with this we come to the end of this lecture. We'll discuss the graphs relating to motion in one dimension in the next class, and we'll also solve some questions.